as is.
Floor is yours, Prasad.
Yeah. Okay. All right. Thank you. Good evening, everybody. So let me share my screen and then we can get started. So, all right. Okay. So probably I will have to, I'll go into presentation mode and then I'll go back and forth to, look at, some text that I have used in between, right? So, okay. All right. So since we are talking about kind of system design and distributed system environment, right? So basically, let's talk about what are the functional requirements first. So you might be asked in the interview to design a system which basically distributes the incoming traffic, right, from the internet, and then see how you can distribute the traffic effectively so that your backend servers are not overloaded. And then what are the scenarios that you can come up with, right? So when you take load balancers, we have two types of load balancers generally in the industry. We talk about layer 4 and layer 7. And then when you talk about the load balancers, mainly it's useful for the HA. It's a high availability in infrastructure, right? And then within that, to avoid certain latencies, and you have different modes or mechanisms that you can use to basically honor the requests, the incoming requests. So we have direct server return, and then you can do network address translations, right? So by the way, if you have any questions, if you want to stop in between, you can ask me to stop, and probably I can clarify any questions we have.
Prasad, can you tell us the difference between layer 4 and 7?
Yeah. So these are the items you will come to know in the subsequent slides. Yeah. Okay, I'll be covering each of the topic that I'm doing as a functional requirement there. So you have subsequent slides to go over. Okay, and then when you talk about the load balancer distributing the traffic, what kind of algorithm that you use, right? So there are different algorithms that we have that we will go through. So essentially, when you design a system, right, like okay, whether you design a layer 4 or a layer 7 system, and what mechanism or the algorithm that you will use for the efficiency, right? Now, so when you talk about your backends and there is incoming traffic for you, so how do you know that your backend is healthy, right? Is it alive, right? Or something went bad and then your backend is not available. So how do you know that? So to increase the availability of backends, there is a mechanism using health checks that you can do basically while forwarding the traffic. You decide, okay, which backends are basically healthy for me to forward the traffic, right? So that is one kind of mechanism that you can use using the health check. And then while you design, you also talk about the capacity, right? So how do you provide, let's say, millions of connections, or this many connections per second, when you have a burst of requests, like, we'll talk about a little bit more details, right? So so when you have burst of things, so many connections per second, how do you handle that? So those kind of things, basically you need to plan, right? So some providers will have the flexible elastic load balancers, few guys might define certain shapes. Okay, so this is 20 gig shape or 25 gig shape, and this shape will give you this many connections or this many CPS and these many active connections at any time in your system, in your load balancers, right? So those are the things that you need to look at. That is one aspect. And the other aspect is basically when you go and deploy that solution, how many nodes are needed. There is a concept called pod, which consists of certain number of hosts in a pod, right? And how many hosts do you need in a pod to take care of this capacity or the request, incoming request. So capacity planning is another requirement that we can touch upon. Okay, so on the non-functional requirements, basically, I just touched upon when the load increases, how do you do that? And then I also mentioned about having a static shape versus the flexibility. If you have provision, auto provisioned your backends or the NLB itself, the capacity itself, then there is a flexibility, as and when the request comes in, if load is increasing, then automatically you'll be able to provision them. Otherwise, you will have to manually look at the capacity every time and then keep increasing the requests. Either you work with your end users to see, okay, so this month, how much capacity you want, and then next month or next next quarter or subsequent quarters, how much capacity do you need? So based on that, you need to do kind of planning for the scalability, right? And then you also have to look at security. Okay, so when you look at the cloud and the latest trend, right? So there are good guys who will be using your cloud efficiently, and there are bad guys who will try to attack and then capture all your data from the servers and or give trouble to your service, right? So there might be attacks, or people intentionally sometimes will open certain half open connections. They will not complete the transaction, right? So I don't know whether I have maybe initially I removed the slide. So in the TCP connection, when you send SYN and completing the transaction, basically they don't give you the ACK from the client side. So the connection will be half open. So if you have such connections open, then your system may not perform well, right? So the newly incoming connections you will not be able to honor, right? So there are various things. And then some connection, let us say you had the data and somebody used it, but after that it's idle, and then you are not using it, right? So then that connection, you have to evict. So after certain idle timeout, you can say, yeah, I'm resetting your connection, come back if you have the data again, right? So then you can establish the connection again. And then you can talk about performances. So if you are trying to reach some server in a different geographical location, then how do you improve your latencies? How efficiently or how quickly you can retrieve the data from your servers? So you can have content delivery networks wherein based on the geography, you will have certain caching kind of content delivery mechanisms. So whoever is nearer to that location will try to give you the cached content rather than going to the server all the way, right? So those are certain things that you can always look at. And when you look at cloud, generally, right, even if you just see a subnet, within that subnet itself you will have multiple buildings, right? And then when certain incoming traffic into your cloud or your subnet, there are various phases, like, maybe a gateway will be taking the traffic and then giving it to your subsequent service. So it will go through multiple services and finally land on your NLB, and then it will go to your backend server. So within that, how do you arrange your buildings such that additional, whatever is the latency that you can, improve, basically, right? So those kind of things also, you can look at when you do the designing. And then, of course, monitoring. When you have a load balancer, if you want to see whether any traffic is coming or not, so there is a listener that will be programmed based on your IP and the port, so which will be looking for the incoming traffic onto the load balancer. So those are the non-functional things. I just gave you an idea. And then okay, the next one, metrics. Basically, when you provide a service, and the end user will expect certain visibility into your service. Or what kind of metrics that you can provide, for me, right? How many active connections are there right now? Or what is the threshold? I mean, I mentioned about a pod consisting of multiple hosts carrying that, traffic, right? So they might say, okay, if the pod is 75% utilized, give me an alarm, right? Some indication, give me some metrics which I can monitor periodically, right? So those kind of things can be also can be discussed as well. Okay, I'll pause here. If you have any questions, let's try to clarify, and then we'll get into the actual load balancing topics.
One quick question, perhaps dumb question.
Yeah.
Generally, we use a term called pod in Kubernetes. So in this case, how does it tally up?
Okay, so I think we are basically talking about the backend server.
Okay,
correct?
pod is you did mention about pod, right? So I suppose you would touch upon some in few slides. In this case, what is pod contextually?
Yeah, contextually. Okay, so let's see. Yeah, so let's say, so let's say you have a load balancer. The pod concept I'm talking about is with respect to load balancer, since we are talking about this, right?
Yeah.
So I'm not talking about the web servers or the database servers. So I'm talking about the load balancer, which is maintained using a pod concept, right? So as I said, I can have 2 hosts in that pod, or like 4 hosts in that pod, or 8 hosts in that pod. And then when you advertise saying my network load balancer will give you a throughput of so much, right? Even when the deployment is happening, that right? So how do you define that? So that is the concept pod I'm talking with respect to NLB, the load balancer.
Can I say pod is nothing but is a group of servers functioning as
Group
load
of
balancer?
hosts, yeah.
I mean, group of hosts functioning as a load balancer.
Correct.
Okay, I see. That makes sense. Thank you.
Okay. All right. Any other questions?
I have another question. You mentioned initially that level 4 and level 7 are they layers 4 and level 7? Are
Layer 4
are you
and
referring
layer
to
7,
TCP?
yes.
Are you referring to TCP layers?
Yeah. So you will come to know. I have a slide there.
Okay.
Yeah. So the layer 4 is a network load balancer, which basically works on the TCP or UDP, and then layer 4 application. Layer 7 application, which basically supports HTTP, HTTPS, even TCP. I mean, I would have given you TCP there. So yeah. Right.
So cloud works on layer 7 for the most part, or they also have TCP?
Yeah,
all the
TCP.
cloud services.
That's what I said. Yeah. So I would have given TCP here as well. Yeah.
So the hardware load balancer will be at layer 4, and the software load balancer will be at level 7.
Yeah, I mean, yeah,
Is that
software,
understanding correct?
you know, yeah, software, you can do it on, maybe I don't have a separate software and hardware thing. So hardware, generally, you know, when you take a cloud, for example, right? So, and take the infrastructure as a service, IaaS, right? So there, you know, basically you talk about NICs and things like that, right? So the network load balance function or the LBAS function. LBAS, when I say, is, you know, layer 7, right? So that's the terminology I'm getting, you know, the Oracle terminology. Sorry for that, but a load balancer, L7 load balancer, right? So using the, you know, NICs, you can do load balancing using that. On the software side, it is just a third-party software, like, you know, for example, F5 or AVI networks, or anybody's, you know, software load balancer that you can take, you can run it on a system, or you can even transfer that to your client itself. So instead of, okay, maybe when we go here, so here, that load balancer, software load balancer can be, you know, pushed to your client itself, so that, you know, client himself can, you know, manage that, you know, load balancer, you know, mechanism using the software, right? So there are, you know, various, you know, mechanisms. Yes, software or, you know, hardware.
Actually, so you said very well. Can I add one more example? Just we recently used network and NLB and regular load balancer. For example,
Sure.
let's say you have a machine where you listen at a particular port, then you go for a network load balancer, or you want to listen at particular HTTP endpoint, right? Let's say you have a HTTP endpoint, and then the request and starting with /ws go to some place, and request starting with slash something go to different place. Then you use regular load balancer like level 7 or layer 7. So
Correct.
layer 4 is if you have a particular port number where you will not get control on the parameters or anything, where it listens at a particular port.
Yes.
Database is an example. Like, let's say you have you want to listen database connections going through a load balancer where there are multiple databases, then you use network load balance.
Yes.
But if for HTTP request, generally we use layer 7
Correct.
regular load.
Correct.
Service specific. So in one term, it is service specific. So each service has to decide like which kind of load balancer they want to use.
Yeah, exactly. That's why, you know, when I mentioned the requirements, right? You know, they might ask you whether, you know, layer 4 or layer 7. Like, you know, it depends on, you know, for which group you are getting interviewed. Maybe, let's say, as part of your, you know, interview question, right? So. Yeah.
So I have one more question. You mentioned about half open connections. When would that happen actually? So normally these are all HTTP connections where you make a request, you get a response, you are done. The connection is not there anymore. So
yeah. So okay, go ahead. Sorry.
Yeah. So then there is no chance that, okay, there is a half open connection. When would that happen?
Yeah. So in fact, I had that slide. I wanted to maybe in the defining, I removed it.
Yeah.
As I said,
let's go through
take
the
the TCP. Let's take the TCP,
Yeah.
right? So you have a SYN going towards your NLB or the backend server, and then SYNAC, right?
Right.
And then ACK to, you know, basically, you know, complete your request, right? So client can, you know, stop sending ACK, saying, you know, my TCP connection is, you know, full now, right? So at that point, your connection is there in NLB because I have done a SYN process and then I have sent you a SYNAC.
I see. Okay.
So my connection is there lingering around. But you haven't given me, the client hasn't given me an ACK to complete a connection and then establish end-to-end for you.
So this is like a low-level manipulation. Got it. Thank you.
Yeah.
Prasad, one thing you talked about the security and DOS, right? Do you have a slide in later, or that's no? If it is, if you are going to talk, I will ask.
Yeah, so since I had it as a non-functional, maybe I didn't add specifically the slide to discuss that.
Okay, maybe at the end, if you have a time, just spend little time on that.
Okay.
That's
Okay.
not-
Yeah.
Okay.
And
I think
also, are we adding any rate limiting at the load balancer? Are we
Yes,
going to
yes.
talk about anything?
that's what
Okay.
I said.
Okay.
Yeah, yeah.
Thank you.
Yeah, can we hold on our questions probably for another 15,
Yeah,
20
let's
minutes,
move
and then
on.
yeah.
Yeah, yeah. You have to do the rate limiting. Yes, yes. Okay,
Okay, sir.
so let's get in. Okay, so let's take this scenario. What is the motivation, for me to have a load balancer, right? So you have an end user, and yeah, he is sending a request to your database via this web server, right? And let's say he opens 10 connections or 10 requests. It's all fine. So your web server should be able to process those requests, and then he will give you the response. Okay, and we talked about 1,000 connections to 100,000 connections. Okay, you have, let's say, a Black Friday event or a December Christmas event. Then what happens? Or your business is growing, right? Then you will have more number of requests coming in. Then how do you manage that, right? You can do, okay, I have increased my CPU capacity, I have increased the RAM, right? Do all your what is called vertical enhancement, right? You can do that. Okay, so from 1,000 I will go to 5,000 connections. Okay, then there is a limit, right? Your CPU may not be able to honor or send the responses as it was sending for 10 requests initially, right? Now you talk about your latencies, throughput, delay, all that, right? And at some point, let's say your server accepts only 100K connections, and then I send 200K connections. What will happen? It will crash, right? So then how do you avoid that situation? What can you do? So you can come up with this approach, right? So okay, let me talk through this, and then I'll show you one more slide in the backup. So you keep something called network load balancer or the load balancer in between, right? So now what did you do? You added additional servers. So you have increased all your capacity of a single server. You're out of capacity there. So now what you can do? You can add more servers to accept your requests, right? So when you do that, how can you distribute the requests to these web servers? Now there should be some mechanism, right? So that is where we talk about these algorithms, or what kind of mechanisms are used while forwarding the traffic to your backends, right? So what you can do here is you can distribute based on certain algorithm. We'll come to that, right? And then evenly distribute this traffic across multiple web servers, so that these three in our example, web servers are happy, and then they can happily give you the response. Everything is fine, right? Even you can ask a question, why you put only one single database server here, right? So I have a backup slide, so you can do this also, right? So I have introduced load balancers in between. So when you, okay, let me call this as your subnet, be it AWS or Google or Oracle or Azure, whatever it is. You can say this is my premises, right? From the internet you get the request, and within my vicinity I can do multiple load balance. So I can give you one public facing IP so that the reachability is there, and then inside I can have my private IPs to manage the service, right? So you can have, instead of one database server, you will have multiple database servers. So you can, basically incrementally do that based on number of requests. So as I said, it can be elastic or it can be capacity-based plan. When I say elastic, you do kind of pre-provisioning. For example, even backends. Let's say you talk about like, Black Friday event or some other, Christmas event, right? So you don't know how much, requests or how much capacity you need to do. If you do any pre-provisioning of your application servers or a web server or the database server, then based on the requests, load balancer can automatically, provide additional capacity for you, right? But if it is manual capacity planning, then you will have to work with user or the client saying, okay, for this event, prior to this event, you had like 2 gig of data coming into my load balancer. So for this event, how much more are you expecting? So additional 10 gig of data. Then inside I'll be provisioning all my backends, network load balancer capacity, web server capacity, everything. You do a manual process, enhance it, keep it ready. Then your request will be honored, right? So that is how you can have a number of load balancers inside, based on how you want to deal with your servers, right? Okay, so now, yeah, I gave like multiple statements here about what load balancer is. I'll just pause for a bit, just read through. It's the same thing. First probably 2-3 bullet points. So by adding this load balancer and increasing your web server or the backend capacity, what you are trying to do is you are avoiding the degradation, right? Because the traffic will be distributed in a certain fashion, in a certain mechanism, which we will come through in the subsequent slides, right? So that way, the degradation will be avoided.
I have one question.
Mhm.
Are there any situations where we should not use load balancer?
We should not use load balancer. So, we can go back to this kind of scenario, right? And then you think about like, okay, how do I get a HA? See, your bottom line. Okay, so let me tell you this one here, right? For example, and then I'll go back again, right? Okay, now let's say I have 3 servers here. One crashed. What will happen?
Mm-hmm.
My service is still there.
Yes.
So the remaining 2 web servers, whatever the traffic that it was absorbing, will be distributed here. So I'm still alive. Whereas in this case, there is no HA for me. Once it is crashed, done.
Right.
So the load balancers come into picture or handy is to give you the HA. That's why when I talked about the requirements here, I quoted that, the high availability, right? So it depends on your application. Okay, I don't want HA, so okay, avoid load balancer. Then how do you manage your service is left to you. You tell me now. Okay, if something goes wrong, or you have reached a capacity where you increased your CPU utilization, number of cores, and the clock cycle, or the RAM, and whatnot, right? Then what will you do?
Mm-hmm.
Right?
Got it.
Okay, so moving on. Okay, as I said, I think we touched upon software and hardware load balancers. Software can be, running on a machine or inside a client, and then hardware can be, when you review the cloud, basically based on the infrastructure as a service, NICs or whatnot, those kind of things. You can run your hardware load balancers, and it can be layer 4 or layer 7. We talked about that, and then this is where the mechanism is coming into picture. So here NLB is doing something. Okay, so there is a stream here, there is a stream here, there is a stream here. So it is trying to do something. What is that? That algorithm is nothing but like, okay, so I have a least connections. What does that mean? I mean, maybe, we can go through a little later. Right? So you have 3 servers. Whoever is having less number of connections at a point, right? Look at that. Get the dynamic update at that point, and then give them the next connection, right? So that's the least connection. Or you can have round robin. Okay, so I'm happy here. Give me one, give me one, give me one, and then do cycle again, right? Round robin. Or weighted load balancing. What is weighted load balancing? Okay, so I have one web server, maybe let's say 1990. I installed it. I mean, Google, when it started, let's say, for example, their such servers, they installed something. It has some capacity in 1990. Okay, so 2000 or 2005. Okay, some enhancements are, something, changed. So you have a bigger system. And then, 2023, you have even better systems, more ports and more memory, right? Okay, now all 3 are serving this, right? Then you can do a weight. Oh, okay. So this can handle only, 5,000. This can handle 100K. This can handle million. Then based on that weight or the capacity of your backend, decide. Okay, so I'll give you some weight. Based on that, I'll give you my algorithm, right? So you can do, various things there, right? Okay, so moving on. Okay, any questions so far?
So Prasad, this load balancer only for initial connection distribution, right? Once a connection is established, it will be out of picture, right?
Yes. Yeah.
Okay.
So that's why, when you discuss any architecture or technical things, there is something called mid-flow. So initial request and the connection ending, termination, and then mid-flow, right? So once the connection is established, you talk about that mid-flow. Mid-flow may not have, much overhead and things like that.
Thank you.
But everything goes through load balancer, right? Load balancer will be there all along. Like for the whole life cycle of the request, load balancer is the middle point, because
Okay.
you don't
So
have.
you are touching on this concept. It's called direct server return. So we'll come to that. I will show you one quick diagram. So this is one scenario where to and fro goes through this. Whereas in the DSR, direct server return, it need not go through this path. It will directly go. So that is also there. So it need
Only
not
response,
go
though,
through.
right? For example, client can never reach your server directly, right? Because they are behind a firewall and all.
Yeah. So that's why, like, two mode will be, always through the network load balancer.
Two more.
For
Yes.
second part, you can skip your network load balancer or the load balancer and then directly go. So this is called direct server return.
So when do you use direct versus regular, actually?
Yeah, I mean, it depends. I mean, if you want to reduce the latencies, that we'll talk through now, right? So
I see.
high performance, efficiency, right? Those kind of things. That's why, even when you looked at this one, I talked through this thing also, right? So it can go through multiple services, within your organization. It can go through gateway, right? Internet gateway or dynamic routing gateway or the service gateway or like, network load balancer or some other, so even when you look at your databases and things like that, right? So database also will be organized in a kind of, load balancer kind of mechanism, right? So there are multiple hubs that, you go through. So if you don't want to go through all that and then, go through directly the client, that's a direct server. So it depends on how many hops and how much time you want to spend within that.
Right. And also, it also depends on your security requirements, whether your server can reach the end client, which is not common, but yes, if needed, we can.
Yeah. So it's a good point that you talked about security, right? So in the forward path, that is indeed the reason, right? So you come through the load balancer so that your backend will have the security rules. Oh, okay. You don't allow like, whoever comes in, right? So, this is my client. This is the IP that I need to honor. So you have a security list, ACLs, sitting there, right? Except, if I, see this particular IP or this particular client or this particular, HTTP or whatever the request is, right? So for the
in case of
security
NAT,
purpose, you can do that on your backends.
One question, in case of NAT, does it have to go through the same load balancer the request came in, or it can go to any of available load balancers?
Say that again. Your NAT thing, is it?
Yeah.
No,
Direct
you're
makes
asking,
sense.
but
Like your load balancer has a series of pod, right? That means multiple nodes. So when the request comes from one of the incoming request comes from one of the node, when the service is returning back the response, let it have to go to the same node back, or it doesn't have to be.
Yes. Yeah. So you, when you use the NAT, right? Yes. There should be a tunneling kind of mechanism that you should maintain when you are leaving the NLB. Otherwise, you don't know where to
I
come.
see. Between pods, they don't have coordination.
Between the that's what
between nodes in a pod, I mean, sorry.
So what happens is, like, as I said, like, it goes through multiple services, right? So when it goes through goes to your next hop, so the next hop should, when the request comes back, you should know the next hop guy or the device should know, okay, where should I send that request to? Okay, and then even the cloud providers, for example, AWS or Oracle or any other guys, right? They may not have a I mean, they generally have something called availability zones or availability domains. Okay, so the response can go to any of your availability domains, right? So for that reason, what they will do is, they will maintain return to sender. There is a concept called return to sender, RTS concept. So that using that RTS concept, NLB will give you certain data to that next guy. So the next guy will use that information and then say, oh, okay, I received this forward path from this, so I will send the request also to that.
I see. That means your connection becomes stateful.
Yes. Yeah.
It's not stateless. Essentially, you need to maintain it where it's coming from. That way you can retrack back.
Correct.
I see. Interesting. Cool. Thank you.
Prasad, this will have a backup. What is the load balancer, or what is the high availability on the? Okay.
Yep. We can do that. So there are various ways. Like, you can have multiple NLBs in an active mode, right? Or you can do. We talked about the pod, right? So pod can also do using certain mechanisms, which I don't want to call out a specific name there, but within
clusters essentially, right?
Within that host itself, like, somebody will always keep track of those connections, right? Even if one guy dies within that, the other guys will still be able to manage that.
I see. I mean, it's an interesting thing you mentioned. Actually, in AWS, load balancers are completely maintained by AWS, so they don't give any failover thing. It is like you mention load balancer, that's it. Failover and all, they take care of it behind the scenes.
Yes.
So then, but for Google and Oracle, is it different?
Yeah, that's why I said I don't want to call the proprietary.
No, I don't think so. When you take a network load balancer or ALB, right? So, and if you turn on like the high availability, they'll take care in the back end.
Yeah.
If you don't turn on, so it is like you're
Yeah.
taking that risk. That's all.
So they're like self-managed, right? So these are self-managed applications. You don't know when they create, how do they create it, and then latency, performance, everything they take care of behind the scenes. They charge for it, but so it is seamless. Normally, we never see like having two load balancers. What we see is having two clusters where one in one region you have one load balancer in let's say one region, West Coast, and one in East Coast, like that. So if one availability zone goes down completely, then you have a backup, but not two load balancers for same request.
Yeah, see, you can do even before your load balancer seat, right? Like through DNS, right? So through DNS also you can control like how you want to distribute, and then the DNS also can monitor. Oh, okay. So is this AD down? I have the path or not? If not, then the DNS choose the other path.
Right, but normally we don't. We don't provision for two load balancers anywhere. We don't see that, right? Because
So that's why I said like it depends like how you want to manage that. Yeah.
Prasad, it seemed like your session requires a sequel.
Yeah.
Like
Let's move on.
And also, Prasad,
one question.
Yeah.
Is it one point of failure, like load balancer? So your DNS is directly connected to your load balancer. If load balancer goes down,
see, that's why like your availability zones or the availability domains, right, will map, and the load balancer host will be mapped. So that's why you will maintain multiple domains. Even if one domain goes down, right, using the distributed mechanism or the fleet that you maintain with multiple hosts in a pod, right, your network load balancer completely will not die, right?
Actually, no. Honestly, the downtime mostly is because of our servers being down, not load balancer. Because
exactly.
Even like millions of requests go through load balancer. The cloud provider manages internally for us.
Exactly.
We never see that, oh, the server is down because load balancer is down. It never happens.
Yes.
The problems come because of our systems, not than the load balancer.
Yeah.
So even they already have the mechanism for failover and all internally. That is not exposed to us because it is the burden by cloud provider, actually.
Correct. See, so that's why when you define your service level agreements, right, you basically say, okay, when one availability domain or the availability zone goes down, and then if we have like 2 or 3 availability zones or domains, how much traffic the remaining can absorb, and how many connections might see if flip because it has to re-establish the connection, right? So so those level agreements will have. So if your product guy says, okay, so this is acceptable within this threshold, you are good.
Yes.
And also, Prasad, I have a question. If one of the node goes down, then what will happen to that request? Okay, we said one node goes down.
Yeah.
So that the new request, the load balancer will route, but what will happen to already the serving request?
Yeah. So already serving connections, if it is going through one AD, for example, or one availability zone, right? Then they will have to re-establish. I mean, the other availability zone has to absorb that. So they will do a re-establishment of the connection, or what can happen is a retry can happen, right? If your system recovers within that period, a retry can be successful as well.
I think he's asking in the context of within a zone. For example, let's say you have 3 nodes you're talking to.
Yeah. So within a zone also, the pool of fleet will maintain the states.
Right.
right? So we'll maintain the states of the connections. Even if one node within a AD or within a pool goes down, still your NLB should be able to absorb that.
Right. Now, how that works is, let's say if you already made a connection and if the node fails, then your request is failing for that. But load balancer has a health check. So subsequent requests would never go there actually.
Yes,
so
sir.
what happens?
No.
I think, isn't it
Health
applications
check
should
is,
take care of this?
between your NLB and the backend, not within your NLB, host, which maintain your NLB, right?
Right. In the sense, let's say
What
I have
is it?
NLB. I have 3 nodes. Then if one of the nodes goes down, then LNB knows that, okay, this node health is bad. I should not send request to that, right?
Yeah. So that's why, within that pool, you maintain the state. So one guy might be, processing all the requests and then trying to push that, context to other remaining hosts within that pool. Okay. So in that case, the other hosts which are up and running will still have the context of your connection. So that will recover, pretty fast. And then the retry mechanism can kick in, and then, your request or data can, pass through.
Prasad, one
I
clarification.
know, like we are diving into like the high availability and all the things. So can we cover the basic part, whatever like the Prasad has it? And we have 10 minutes only. I'm okay to stay like how long we want, but let's cover the content and we can ask all the questions that you guys have. We can spend time.
Let's have an uninterrupted session for next sometime. Maybe 10
Oh yeah. I mean, if you want to continue, yes, so we can do that.
Or maybe,
but
honestly, if we can have a security session, maybe follow-up session.
No, Swami, we can talk actually, like let's Prasad complete it.
Yeah,
let's
sure.
not jump to
Yes, sir.
security or any of those right now. Okay. I know you are so much interested on some of the deeper things, but let's cover the surface and then we'll go into the deep.
Yeah. Okay. So, okay. So where are we? So performance, right? So, okay, load balancer. Okay. So we talked about, like, okay, when you don't have load balancer, your one particular server can be overloaded with too many requests. So by the time the CPU process it and then sends the response back, right? So that can take, some time, right? Whereas when you have a load balancer, you have some kind of, distribution, so that your CPUs, within those, web servers or the backends, will, work efficiently, and then it will minimize, your response time. It will be quicker, right? So when you have, efficient, CPU utilization to process those requests. So that's why, like, you will have, throughput, maximized, throughput. And then, high availability is the main thing, that we have been talking about. So that serves the purpose. And then this is the key here, essentially, between the load balancer and your backend, right? So the beauty of the load balancer is it will generate certain health checks. Okay, I have, 10 or like, 100 or thousands of, backends, but before a packet is, destined to any of this server, how do I know that this particular, backend is healthy, or, it went down, it crashed? You don't know, right? So that's why there is a periodic mechanism using the health checks that NLB will, generate. It will try to establish, some mechanism to see, okay, and out of 10, 9 are healthy, and then 1 is bad. So I will not send any traffic to that one particular backend, right? So that is the beauty of this health check. Will, decide so that black holing of, traffic will not be there. Okay, so load balancer do continuous health checks. Okay, I think it's the same thing. So the server's capability, is known, and then increase the scalability. So as I said, like, okay, so based on the number of requests that you are, getting in, whether, you can do auto scale of your backends, or your, NLB itself how much throughput that NLB can accept, right? So you can keep adding, pool of, hosts or the pods, within NLB or within your backend set, right? So that can be, done using this mechanism. Okay, and then, we talked about layer 4 and layer 7, right? So somebody asked initially, so let's go through this. So yeah, so TCP, UDP here, and then HTTP, HTTPS, and then even TCP here, right? And then the decision, basically, right? So what you can use is your source IP, your TCP or UDP ports, or the destination IP. The combinations can be used to, send the traffic as well, right? So we talked about the ways, the least connections, weighted, round robin, and all that, right? Apart from that, you also, look at your source IP, destination IP, or the port, and then you can decide as well, right? So there is something called 5-tuple, 3-tuple, or 2-tuple kind of mechanisms which are available. So if you have 5-tuple, like, source, destination, protocol, and source port, destination port, the combination, or only 3 among them, or 2 among them, source and destination IP. The combinations you can use, and then you can do that. So the main difference I'll talk through now is, between layer 4 and layer 7 is, layer 4 is basically a pass-through mechanism, whereas the layer 7, it's a connection termination. So L7 generally, terminates the connection on the load balancer, and then re-establish the connection from the load balancer to your backend, right? So that is the major difference. And if somebody wants a low latency, means, you don't even look at your inside packet processing, termination, and all of that can be avoided. So use your layer 4, right? And then, if you want to do some secured kind of, mechanism for your HTTP traffic, then, you can terminate, you can look at the, content, whether you want to look at the path, host, and, various other, sessions and all that, and then, process that, right? So that's the major difference. And then, we talked about the security, the security main thing on the back end, right? If I know the source from where the packet is coming, right, then it is good for me to have my security rules defined, right? So for that reason, L4 will preserve your, source IP, right? Because I'm not touching, my headers, right? All I am doing is, I'm doing a network address translation or the DSR mode that I am doing, right? Or in case if, you cannot do that, there is something called proxy protocol, PPV2. So that protocol will have a provision to provide your backend information, right? Or whatever is the device IDs and certain information specific to your organization, that information can be, given using the proxy protocol. And with that, you can also, provide your source and destination on all other fields inside that, PPV2 headers, right? And in this case, as I said, like, it is terminated, and then you do encryption, decryption, and then if you want to modify your headers, you can modify all of that, right? So that is, L7. So I have given some text here. Just I'll, briefly keep it here. It's a too much text which I copied from A10 or somewhere, some website.
Yeah.
So,
Prasad, I'll share the deck with everyone. So, interest of time, probably you can move to
okay.
the next one.
Yeah.
People
All
to
right.
read
Yeah.
offline this one.
So yeah. Okay, cool. All right. Okay, so yeah. Okay, so now let's go a little bit deep into this. how is this achieved, right? So it is you basically achieved using the virtual IP and dedicated IP approach, right? And then we talked about NAT and DSR. So let me jump onto this. So if you look at this, right? So I mean, forget about this part. Just only look at this part, for example, right? So if you look at this, there is only one virtual IP which is common, right? Even though it's a different hardware which is having a dedicated IP, right? 1.2, 1.3, 1.4, 1.5, whereas the virtual IP that will be exposed to the end user is mainly your virtual IP. So using virtual IP, it will reach the NLB or the load balancer, and the load balancer will decide, oh, okay, so I have multiple backends here. How do I translate that and then send the request to this dedicated IPs, right? So that is how basically it is achieved.
Prasad, is the ECMP based out of it? It comes to one of the NLBs.
No, I mean, see, that ECMP you can think of even prior to it is even reaching your NLB stage. After that, it's all based on your virtual IPs. So
Akhil, is it
ECMP will decide how your traffic will flow through from the internet onto your NLB. See, here my mechanism is least connections, or 5-tuple hash based mechanism, or weighted round robin, those kind of things, right? So towards my backends, the NLB will use some of these mechanisms.
Correct. When a client sends a request to a virtual IP, which network load balancer it will land? That is something I didn't get.
Yeah. So that is again it is even much ahead, your DNS. Let the end users DNS define, okay, so which load balancer or which AD or availability zone it pass through. It depends. That can be controlled at a much higher level, DNS level. Okay. So yeah, so we touched upon this. So yeah, as I said, if you don't want to come back, add additional latencies, overheads within that, yeah, I mean, request came in securely, you are good, server is responding back, go directly to client, right? Okay, so another variant of DSR, basically direct server return, so load balancer, and then it doesn't come back to load balancer, essentially it goes through. And then NAT here. So if you see this, right? So the request coming from the source, which is client, and the destination is my virtual IP, right? It's a VIP. It comes here, and then now when the packet gets forwarded to your backend by the load balancer becomes a source, and the actual destination IP, the physical IP will become your server destination, and then the same thing in the reply path. So that is how you do the network address translation within that. Okay, so yeah, so we briefly touched upon, so I have given a little bit more information here. You have static mechanisms. You can do round robin, weighted round robin, source IP hash, URL hash, or dynamic. When we say dynamic, essentially you will have a feedback mechanism essentially between your backends and this one, the load balancer, to see at that instance what is the snapshot. It's a dynamic thing, right? So you understand, okay, this particular backend has certain connections. So you take that, and based on that you decide these mechanisms are called dynamic algorithms basically. right? Okay, so this is where I have used some information. We should be careful, maybe if you want to stop one resource. So this is one, good resource for reading, right? So you can read through vertical scaling, horizontal scaling, throughputs, responses, right?
Okay.
So
Yeah, I mean, they compared rate limiting and load balancing and all of that, but yeah, right. So, and this is another thing from the same similar thing, how the load balancer work, what kind of algorithms, right? When to use the load balancer, advantages, right? And this is Nginx actually. So this is another software balancer, so load balancer, right? So yeah, this also has good information. Some videos are there, and then even yeah, even this one talks about some health checks, whatnot. And A10, as I mentioned, like I took that content as is, right? So layer 4, layer 7 information that I cut pasted there. I mean, these are the yeah. So this is one resource. I thought of picking up some information here, but I could not fit that in my flow. So if you see here, right, so it's a layer 7. So they clearly, showed, okay, so when you reach the backend, like, how do they segregate, the request, right? So
It's a basically payload based, I think, right? As a
yeah.
protocol based. Yeah.
Yeah. So even like, they talked about layer 4, layer 7. There are, very good number of, I mean, you will see slightly different terminology and things like that, but bottom line, hardware load balancer, software load balancer, your mechanism, HA, and then what kind of algorithms you use. It's all, that. And probably this is another thing, yeah, in fact, I thought of showing you this when I'm talking about the algorithms, right? So round robin. So they clearly stated like, how the requests are, done here. And there is some code which we really don't worry. So weighted round robin algorithm, random load balancing, IP. So if you want to use your IP hash algorithm, URL hash, least connection method, weighted least connection, right? All these things. Let me see. Yeah, so this is the DSR and things like that. Yeah. So these are, additional resources I was just referring to, getting some data, so that, we can talk through.
yeah, Prasad, so in your references slide, you can add all of these.
Yeah. So I added,
website.
some of those references are there indeed in the thing. I'll cross check. Sorry, this is word.
Yeah. Thanks, Prasad. It's already like 9:14. So unless someone has like any pestering question, so yeah, I want to thank Prasad for accepting my invitation and coming and giving a talk on like load balancer. Hope this session is helpful to everyone. Before you all drop off, okay, first say thank you to like Prasad, send your thank you
Hey,
note,
come on.
and
No,
there is actually like an announcement.
Yeah. So
Go ahead,
I did
Prasad.
my best. So when Srinivas reached out to me, I said, okay, let's do this. Let's challenge, myself and then see how I can do that. Right. So in front of some audience who I haven't interacted with. Right. So, okay. So I tried my best to give you and then, answer in some of the questions. Hope, it's useful.
Yeah. Thanks, Prasad. So before you all drop off, we have like a small announcement. I'm stopping the recording, and then there's an announcement from Srinath.